All right, at the end of the last lecture, we went through and solved this compound inequality where it was an OR connector, and we ended up with x less than or equal to 2 or x is greater than 15. And when we compared the graphs, the OR was a union of both graphs. So we basically, the solution involves both graphs. But what happens if we wanted to solve the same inequality, but it was an AND connector? So what happens if we change this to AND? And AND is an intersection, or when we look at the union, or I mean, excuse me, intersection of the two sets. Okay, so what's the difference? Well, I still go through and solve. So I would still, in the first step, I would still end up getting x less than or equal to 2 and x greater than 15. Okay, so I'd still end up with that. I still would need to do that. And I would still compare the graphs on adjacent number lines. And I'm just going to draw my number lines this time. So I'm going to make them adjacent number lines. And x less than or equal to 2. Maybe the 2 is over here somewhere. So I make sure when I line up my number lines that the 2 is at the same space. Less than or equal to would be everything to the left. So this is x less than or equal to 2. X greater than 15. Well, 15 is to the right, so anywhere to the right. But again, I want to line up my graphs. It'll be an open circle and everything to the right. But now when I compare these, I'm actually looking for the intersection of these two, or the overlap. And if we look at the overlap, and again, when we do this third part, we're drawing another line, and we're looking for overlap of the two solutions, and there's no overlap. We notice that these two solutions do not overlap, so there's no overlap. Therefore, the answer is no solution. So that's actually our answer. For this compound inequality, since there's no overlap, there's no solution. Now, with sets, there's different ways to say that. Now, no solution is totally fine, but you might see stuff like the empty set to signify no solution, or there's no elements in the set. And an empty set is usually symbolized with two set brackets with nothing in them, or a circle with a line through it would represent an empty set. So either one of those solutions, if you say no solution, that's okay. If you say the empty set and you use the brackets or the circle with the line through it, that's okay to represent your answers. But this brings us to identities and contradictions. So when we get something that's no solution, it usually comes from a contradiction of sorts. In this case, the contradiction is there's no elements in both of those inequalities. There's nothing overlapping. So if we were to solve types of questions like this, what are some things that would come up? So let's solve this inequality. First thing, we're going to solve both inequalities by themselves. So solving each, on the left side, we'll subtract 3 from both sides. We get negative 4x is less than or equal to negative 12. And then we want to cancel the negative 4, or divide by negative 4. And again, here we're attaching a negative factor, so we want to make sure we flip the inequality symbol, so that would be greater than or equal to. The left side would be x, and the right side would be positive 3. So that's the inequality on the left, and solving on the right, we just need to multiply both sides by 2. and we would end up with x is less than -2. So I'm looking for an and. So again, we're going to graph these on adjacent number lines. So we're going to compare our on adjacent number lines. So the first one, x greater than or equal to 3, would be everything greater than or equal to 3. And then x less than -2. -2 is here, it's open circle to the left. And then your third step is to look for the and, which is an intersection, which is overlap. So again, here, overlap, there is no overlap, right? So these two inequalities, these two number lines do not overlap. So therefore, there's no solution to our compound inequality. So it's looking for the and there's no overlap, so there's no solution. Or we could just say that the answer is the empty set. So I want to compare that to this problem, and it's pretty much the same, but I did change, and I want you to do this in your notes. Change that -1 with the inequality on the right. Change that to a +2. So if I solve the inequality on the left, it's the same inequality as it was above, so I'll get x is greater than or equal to 3. Or, now again, this is an or, which is a union, right? And then if we multiply both sides by 2 here, we're going to get x is less than 4. So here's our two inequalities. Again, we're going to compare these inequalities, x greater than or equal to 3. So here's 3, it would be a closed circle and everything to the right. And then x less than 4, well, 4 is here with an open circle and everything to the left. And now, in our step 3, we're looking for an OR connector, which is a union, which is basically both solutions, right? Both inequalities, both solutions, right? So the solution includes both of these. And if you think, if I graph the first one, x is greater than or equal to 3, and then on top of this line, I'm going to graph everything less than 4, you'll notice that the number line is completely filled in. So the solution, and this is the graph of our, this is the graph of our solution. If I'm looking for a union or, it would actually involve everything. So what's our answer to this? Well, when every number is a solution, it's called an identity. And so we could say all real numbers. That's one way we could say this. Or we could use an interval notation. And basically go from -infinity to infinity. So the left is -infinity, the right is infinity, and this is just a way to write all real numbers as a solution. It doesn't really make sense to graph the solution. It would just be a solid line going left and right. So a lot of times we just refer to an identity where we have all real numbers as an answer. We usually use the interval notation -infinity to infinity to represent any real number. Okay,